Hi, I'm Jackson Barlow, and today I'm going to be talking about React bundled with Three.js. So what exactly is Three.js? Well, 3 is a JavaScript library that allows for 3D graphics rendering, and it's open source and uses WebGL as its engine, and it lets you display graphics on the web. So this right here on the right, this GIF, it was actually modeled using Blender, but the cool thing about 3 is you can import your Blender models and animations and use it on your website. 3 uses your computer's graphics card to optimize parallel re-rendering and not just use your computer's processor for all rendering. How can I use Three.js? Well, you can implement it in any React project, so anything with Next or React apps or Vite apps or just any JavaScript framework. And you can use built-in objects and methods that will display 3D geometries. And you can also make it reactive to user input on the site. So anything with state and any changes to state, you can re-render your different 3D graphics depending on state variables. And you put any references to the 3 library inside of useEffect so that you can re-render. So one really key part of 3 is understanding the useEffect hook and how it works. So the useEffect hook allows you to keep components synchronized with external systems. So for example, we have like database queries or things like 3, which are animation libraries. And an external system is anything that isn't controlled by React, but rather it's coming from some other source. If we were to leave the 3D scene outside of useEffect and simply put it inside the component, anytime the component is re-rendered, it would create an entire new scene, which is very processor and graphics card intensive. So we keep it inside of the useEffect hook. And as we can see right here from this diagram, the useEffect takes 2 parameters, which is the effect and the dependencies. The effect is what we want to happen when the function is called. So for example, if we keep the dependencies empty, it's an array. So if we keep it empty, then the effect will run only on the first time the object renders. And we want it to be able to re-render itself separately from the component. So now let's dive into some of the basics of 3. Every 3 implementation consists of a scene, a camera, and a renderer. The scene is pretty much the container or where all the 3D objects are inside of. The camera is how you want to view the object. So whether it's like perspective or orthographic. So like perspective is kind of how we would see an object. And we also have the renderer, which is essentially how we want to be able to link the scene to our web page. So now let's jump into a simple example. So in this example right here, we have, it's really just 2 divs, and one just has a little bit of text and the other is the container for our scene. So we see the camera spinning around and just rotating around the torus, and we can actually rotate around it with our mouse too, and we can see one single light source right here, which is known as a point light that's illuminating our donut. Don't ask why it's green, I can't tell you. So taking a look at the code right here, we notice the import statements, and we import useRef and useEffect. And with useRef, we can keep track of the reference to the container. And we also use the useEffect so that we can just render it once, and we can constantly change it throughout the process and constantly re-render the scene but not re-render the whole page. Breaking it down, I was talking about how every single 3 page needs a scene, it needs a camera, and it needs a renderer. So we can instantiate those objects with scene equals new 3.scene, and it'll return the object, and camera equals new 3.perspective camera, and this just makes a camera that mimics how you and I would be able to see the objects. And it takes parameters of the field of view, the aspect ratio, and these 2 are the clipping. So when this number is really low, then you can see like objects really close to you, and when this one is really high, you can see things really far from you. And we can just set the initial position of the camera so that we can see the donut, and I just set it to a little bit back and a little bit up. So thirdly, we have to instantiate the renderer, and this uses anti-aliasing, which just makes objects appear smoother and more textured. And you can set the pixel ratio and the size, and then add it to the current mount. So recall, we just set it in the div, so our div is going to be the mount for the scene. So it's just the top left corner where the scene is pretty much going to be. So once we have all of those three, then we can actually start to create the objects. So in our case, we're making a donut. So we can make the donut by using the built-in 3 objects. So this one has the torus geometry, and we can just set the parameters of the size, and we can also change the material. So if we imagine the material as like a wrapping paper for the geometry, then we can like set the color of the objects, we can set the texture. For this case, I just used green. I mean, if you want, you can import like a JPEG and have it so that it has some custom texture. And then we just create the mesh. So the mesh combines the material and the geometry. And then we can add it to the scene with scene.add. So here I made one other geometry, which is the floor. So the floor is by default vertical, so we have to flip it along the x-axis, and we can do that by changing the rotation of it. So we set the rotation to -pi/2, and that flips it 90 degrees. And then we can also lower the initial position. It defaults to 0, but if we set it to -12, then it'll be a little bit lower so that it's resting under our donut instead of in the middle of it. And then, like all meshes and objects, we have to add them to the scene. So now let's get into the lighting aspect of this. In my case, I used a point light, but you can also use an ambient light, which lights up the entire scene equally. Or you can use a source light, which is just a light that comes from the sky. It's like the sun. But with a point light, it's just a single point that light illuminates equally from that point. And I made a white light with an intensity of 2.5 and a fall off rating of 0.7. So it's just how much it dims over distance. And this just sets the initial position of it with pointlight.position.set, and then you can just add it to the scene. And one thing that I found was really helpful was adding a helper. So 3 includes multiple helpers. You can use a grid helper to help visualize where the grid is. You can use an axes helper to see what X, Y, and Z axes are. And you can use a light helper, which shows you where the lights are and doesn't just have the light emanating from nowhere. So the next component of this is the orbit controls. And with the orbit controls, that's what allows you to pan back and forth and be able to see it from different angles, even though it's spinning. So all you have to do is just import the orbit controls package and instantiate the object and pass it your camera and the DOM element that belongs to the renderer. So if we set auto rotate to true, then that allows it to just spin on its own, and you can set the speed, and with the max polar angle, that just makes it so that you can't pan below the floor. So the next part that all the components have is an animate function. And the best analogy for the animate function is it's kind of like a game loop in the sense that it just keeps running recursively, and it just requests the frame to animate and updates the controls and re-renders the scene constantly on an asynchronous loop using your computer's graphics card and not the processor. So now we're getting down to the part where we contain our HTML elements. And in the left half of the screen, it's just a div that uses Flexbox, and it contains half of it, and it just says welcome to 3JS. And then on the right half, this is where our scene and our mount is stored. So we have our mount reference, and we have our style, which is just taking up 100% of the width of the parent container and 100% of the height of the viewport. So essentially, this makes it so that it'll take up half the screen with our hello, welcome to 3JS, and the other half with our scene. And then when we combine all of this together, we get our green spinning donut with a single point light. And it's pretty cool. I really like how you can pan around it. And one aspect that I haven't really explored yet is the ability to import scenes from Blender. So whatever you can 3D model, you can actually use with Three.js. But that's pretty much the gist of it. Thank you so much for watching and have a good one. Thank you.